George here. Happy Valentine's Day. For this month's electronics project build, we will be building this throbbing Valentine's heart. Let's get started. Today we will be assembling this Valentine's Day heart. We have the circuit board, 5 resistors, an electric-lytic capacitor, a transistor, a variable resistor, a button, and an LM358. And of course, a bag of a bunch of LEDs, which will go around the outer parameter of the heart. I'm adding to the kit a 8-pin dip socket, dual inline package. That's what that is, dual inline package. So I'm adding a socket so that the chip, I'm not soldering the chip directly to the board. I can replace the chip if need be, or if I need to use the chip in a different project, I could take it off easily. And of course, a AA battery box. This circuit calls for 6 volts. 4 AA's will be 6 volts. So because each AA is 1.5 volts. Anyways, we're going to start off with the resistors. Resistors have color codes on them, and that will tell you the value. So let me demonstrate. Looking at the color chart, you'll see that there is a different value for each of the colors, and also a multiplier. The first 2 colors on the resistor are numbers, values. The third color is the multiplier, and there's often a fourth one, which is usually a gold or a silver color band. That is just a tolerance level. We don't really need to worry about that. So these particular resistors are yellow, purple, and orange. So yellow is 4, purple is 7, and the multiplier, orange, is 1000. So this will be 47,000 ohms, or 47 kilo ohms. So these are the 47Ks. This one right here is brown or black orange. So brown is 1, black is 0, and the orange represents 1000. So that would be 10,000. So this is 10 kilo ohms. This one right here is red, red, black. So that will be 2, 2, and the multiplier is 1. So this is a 22 ohm resistor. Notice how I did not say kilo ohm because there's no 1000. It's just 22. So since it's less than 1000, it's just an ohm. So 22 ohms. This one right here is a brown, black, and yellow. So brown is 1, black is 0, and yellow means 10,000. So this would be a 1, 0 times 10,000 is 100,000. So this is a 100K kilo ohm resistor. So let's go ahead and install these resistors. I'm just going to put them where they go on a board. Go ahead and bend the leads at the base of the resistor and stick them onto the board. The board is labeled the values of the resistors where they go. So since this is a 47K, I will put it on the spot that says 47K. Resistors are not polarized, so it doesn't matter which way they go on. But I'm going to try to have the color bands go in the same direction just so that it looks nice. Once I get the resistors on, I'm just going to bend the leads back. That way they'll just stay in place when I go to solder them. Bend, bend. When you're putting together a circuit, it's always a good idea doing the smallest components first. There are some exceptions to that, but in this one, I'm going to follow that rule. Okay, so the 10K resistor will be the brown, black, and orange. I'm going to put this where the 10K resistor goes. Okay. And the 22 ohm resistor, which is represented on the board right here as a 22R. I'll just stick that right here. Moving the leads in. Stick it onto the board as so. And that means we have one more resistor, which is the 100K resistor. So we'll put that on the board where it says 100K. Excellent. Alright, we are ready to solder. Just going to move these components out of the way here and get my... Well, I don't think my normal jig is going to work for this, so we're going to have to use the helping hands, which is not my favorite tool to use, but this will not stick and stay in my blue jig. Oh well. So I'm going to just stick this on the helping hands. Try to position it so that I can solder more easily. There we go. Proper soldering technique. Place the soldering iron on the pad. You heat up the surface, wait a second, and then you apply the solder. You should get a decent ball there, but not too much and not too little. If you immediately touch the solder to the tip of the soldering iron, all you do is add solder to the tip of the soldering iron and not onto the board. You also want to clean the surface of your soldering iron to remove any excess solder. So I'm just going to continue to add solder to all of these. Oh, and also probably be a good idea turning the ventilation on. So I have a fume extractor here, so I'm not breathing in. I am using a leaded solder. Okay. Down for a second so I can adjust this. Move the board around to make it easier to solder. Obviously, you don't want to have to hold the soldering iron at an awkward angle or anything. Okay. That looks good. Well, now what I'm going to do is I'm just going to look at my soldering underneath a magnifying glass. Just make sure there are no shorts and that everything looks good. Excellent. And now I'm just going to bend the leads back up so I can trim them off. I'm using a flat edge trimmer so that I can go against the end of the wire here and just snip off the excess material. Good idea to hold on to the board and the pin because the pins tend to fly and they're like little sharp little needles, so You don't want them to fly into your eye or land on the floor and step on later. And as you can see, that is nicely cleaned up. Beautiful surface. Next on the agenda, we will be soldering the capacitor. This is an electrolytic capacitor, and it has a positive and negative lead. The positive lead is usually the longer one, but the negative lead is indicated by a white stripe. The circuit board has an indication on it where the positive lead is, and also an indication where the negative lead is. You can see that the positive has a positive mark next to it, and the circle, the half circle where the negative goes in, is shaded in. So we will install the electrolytic capacitor in the correct orientation. Just going to bend the leads back a little bit to hold it in place and proceed to solder. Okay. Again, inspect the soldering under the magnifying glass. Looks good. So I'll proceed to trim off the leads. The transistor. This is an S8050 transistor. This transistor has 3 leads: the emitter, base, and collector. With the flat end of the transistor facing you, the middle pin is the base, the left pin is the emitter, and the right pin is the collector. When current is present at the base, the transistor allows current to flow from the collector to the emitter. Insert the transistor with the flat end of the transistor facing the flat end of the transistor symbol on the board. And just bend some of these leads to hold it in place, and let's proceed to solder. Yeah. That's what you gotta watch out for. Alright, if you do create a bridge, you need to remove the solder. So I'm going to use some desoldering wick. That way bridges only get soldered between more than one pin. So what I'm going to do is I'm just going to add this wick to the board, place the soldering on it, soldering iron on it, and that will absorb the solder. That remove the solder from those 2 pins. So, make sure I have a clean tip here. Okay. Alright, now I'm going to trim the leads off the transistor. And that should be done. Just going to clean that up a little bit. Do a little 90% rubbing alcohol. I'm just going to clean off the burned flux. Make it look nicer. Give some more time. I'm going to inspect soldering. And I don't like the middle pin. Apply just a little bit more solder to the middle pin. If you don't have enough solder on it, it's probably not going to get a very good connection. It's much better. Okay. Now the transistor is installed. Now we're going to install the DIP socket. DIP means dual inline package. That's what this chip is, the dual inline package. It's just basically the type of container the chip is. The chip and dual inline package socket, and we're just going to call it DIP socket for short, has a little bump at the end. That bump represents the end that pin 1 will be located. The bump is also represented on the circuit board. So you want to put the DIP socket onto the board with the indent matching up with the indent on the symbol on the board. And of course, sometimes you have to unbend the pins so they can fit in here. Okay? Alright. I'm going to get a small piece of electrical tape just to hold the socket on while I solder it. Just to make things a little easier for me. Put my hands out of the way here. Or I can just use it to hold on to the right. Use thin solder for this. I'm just going to solder each corner. That'll give us some stability before I solder the other pins. underneath the... Looks pretty good. Next, I'm going to install the button. I'm just going to place the button right here, using a piece of electrical tape to hold it on. And then I'm just going to solder the individual leads. Just do one corner first and then the other corner. I need to use the helping hands to hold it in place. I don't want to solder the soldering iron, I want to solder the leads. So it looks like I'm at a bridge. Looks pretty good. Yeah. So I'm going to now clean up this some rubbing alcohol to get rid of the burnt flux. It looks a lot better. And inspect this underneath the magnifying glass. And that looks good. And the push button is installed. Push it down to turn it on, push it up and down again, and it turns back off. Okay, next we're going to install the potentiometer, or also known as a variable resistor. So this is going to be pretty easy. Stick it on the board like so, and then just solder the terminals. Stick this into the helping hands. Beautiful. Alright, now it's time to install the LEDs. LED stands for light emitting diode. They are a special kind of diode that obviously emits light when you pass current through it. And just like regular diodes, current can only flow through one way, so they are polarized. The longer lead is usually the positive, and the shorter lead is the negative. A lot of times the negative would also be represented by a flat edge on the LED, but not always. On a circuit board, the positive lead will go right in front of the flat surface of the triangle. The negative lead will face the flat surface of the LED symbol. So the LED would go in like this. And then we're just going to flatten it down and bend the leads out to hold it. So we're going to install all these LEDs around the parameter of this part. Alright, we now got all the LEDs in place here. Time to solder. What I mean by solder is a lot of soldering. So I'm just going to rearrange some of these pins here because they're in the way. Or we're going to just move them when we're done with them. So, this almost hurts to look at. I just have the outside pins soldered right now. Okay, now it's time to inspect underneath the magnifying glass. Make sure we don't have any nasty shorts like right here. Alright, the last thing we're going to add is the battery box. So, well, second to last. We also got the LM358 to add, but we're going to get it after the battery box. So, they have two holes here for the wires to go through, but the insulation on this is just too wide. So, that's not going to work. So what I'm going to do is I'm just going to solder directly to the board here. Positive is the inside one, so just trim this down just a tiny bit. Tin this. Helping hands to hold on. Here's the inside. Beautiful. Alright. And the general idea is just to tape this down in the back. But till then, you know, let's just trim these leads down. So we don't short out anything. Kind of hard to reach in there. Magnifying glass. Oh yeah. Now let's install the LM358. The end of the chip has a little notch, so that should match up with the notch on the board, or if you used a dip socket with a dip socket. So we'll just push the chip in like so. And let's see if we are successful in making a circuit here. Install 4 AA batteries, which will give us a total of 6 volts. Alright. Who wants to place a bet if this will work or not? Ooh. Oh, the heart is throbbing. You see it? Oh man.